Alright, here we're looking at section 5.3. The learning targets for this section is I can graph radical functions, I can write the transformations of radical functions, and we'll talk more about transformations, and then I can graph parabolas and circles. So the first thing we really want to look at is our parent functions. Whenever we're graphing functions, we always start with the parent, which is just kind of the general function, and then we add some transformations to it. So here on this page, you can see my parent functions for my square root and my cube root functions. Okay, so here is my square root function. This is just the square root of x, right? This is my first radical function we're looking at. So we can see that my domain, right, and domain is going to be my x values. And the way that I remember domain and range is domain has a d, range is an r, and d comes before r in the alphabet, and x comes before y in the alphabet. So the d goes with the x, and the r goes with a y. So my domain here is if I'm looking at this graph, I don't see any part of my graph down here until I hit the origin. So I know that my domain is where x is greater than 0. So then looking at my range, I look at all my y values. And I see I don't have any part of my graph down below the x-axis, so I know that my range is y is greater than 0. Okay, so this example over here, this is my cube root function, right? So I have the 3 outside, so I'm taking the cube root of x. The domain and range change here. So my domain and range on my cube root functions are always going to be all real numbers because it continues off in both directions, in the x to infinity and in the y to infinity. So we're going to be using these two functions and then transforming them to get our new graphs. So if we're looking at example 1, we're going to be graphing these two different functions and looking for the domain and range. So the first thing I want to do when I'm graphing a function, if I don't know what it looks like automatically, is I make a table of values and then I sketch my graph. So here are some values that I picked, right? So I always just pick some x values and then I can graph the corresponding y values. The x values that I pick, I usually want to pick 0 because it simplifies things. The reason that these values were picked, the 4, 8, 12, and 16, is because if I look at this fraction, I'm looking at 1/4. So if I pick an x value that's a factor of 4, or that's a multiple of 4, I can simplify and get whole number solutions, which kind of makes things easier. So then I put that into my calculator and I get my corresponding y values, and then I just plot those. So I see that my x and y is 0, 0, so I plot that point right here. My next coordinate point was 4, 1, which is graphed here, then 8, and then 1.41. So I graph each individual point, and so then I can look at it. So based on what we know about domain and range, I can see that my domain, right, my x values, are still x is greater than or equal to 0. Same for my y values. My graph never goes below the x-axis, so my y is greater than or equal to 0 as well. So what we know too is we never want to have a negative value inside my radical sign. That creates an imaginary number, which we'll talk about some more later, but for now we don't want that. So I know that my domain has to be greater than 0, because if it's less than, then I'm going to end up with a negative value, and we don't want to go there. Okay, so now let's look at this second example, a negative 3 times a cube root of x. So again, I want to make a table of values and sketch the graph. So here, since I'm looking at the cube root function, I always start with 0. It's just a simple place to start. But then I come up with a couple of positive values and a couple of negative values to add to my table so I can sketch it. So I plug each of these in to my original equation. I come up with the y value, and then I can graph it and see what it looks like. So I know that if I'm looking at a cube root function, right, with that 3 outside, I know that my domain is always going to be any real number, and my range is also going to be all real numbers. So that's my domain and range for that one. Okay. So here we're looking at transformations. So we always want to start with our parent function, which you saw a few slides ago, and then we use our transformations to get our new equation. So a horizontal translation, which shifts it left and right. The biggest thing to note here is you'll see this negative sign in here. This is where things kind of get tricky. So you'll see in this example, if I have x minus 2, even though this is a subtraction, I actually go 2 units to the right. One thing also to note is horizontal translation. This number is inside the parentheses, so it will be underneath the radical sign. It's inside the radical sign. Unlike this vertical translation that shifts my graph up and down, it's outside the parentheses, so the number is outside the radical sign. It's not underneath with it. That's how I can tell these two apart, whether it goes side to side or up and down. I can also have some reflection, where my graph reflects or flips over my axis. So if my negative sign is inside underneath the radical sign, it flips across the y-axis. If it's outside, as in this example, it flips across the x-axis. My graph can also stretch and shrink. So if my a value, or you'll see in a minute what I call the b value, is inside the radical sign, it stretches it horizontally. If it's outside there, it stretches or shrinks it vertically. So here's a really cool website. This is Desmos. So what I've done here is I've just created my parent functions. You'll see this red graph that I have graphed is just a generic radical square root function with a, b, h, and k. These are the values that we just looked at in here. So this value right here, this horizontal stretch, I called b instead of a. Okay, so then what I can do is I can just change all of these values. So if my a, which is outside, increases, right, it stretches my graph vertically. If my b value increases, it stretches horizontally. Okay, and those two look very similar. You'll see some differences here pretty soon. So my h, remember, my h moves things horizontally. So if I move my h getting bigger, it's going to move that way. So my h value moves in my horizontal translation. And my k is my vertical translation. It goes up and down. So what I can see is these are the same things as in my cube root function. So this purple graph is the parent cube root function. And I can move these sliders around as well. If you ever want to play with this, you can do this yourself. You can just go to desmos.com and then open a new calculator and type this in. If you type in letters, it'll ask you if you want to add sliders, and you just say yes, you want to add the sliders. Okay, so these would be good things to just kind of remember, and even draw yourself or write yourself an example so you have several examples. So we're going to use them here right now. We're going to describe the transformation that's represented. So my first function, my f of x, I see as the square root of x. I'm transforming it here to get g of x. So what I see is I have an h value, something underneath the radical sign, and a k value, something outside the radical sign. So my h value is 3, and my k value is 4. So I know that this h value of 3 would translate it 3 to the right, and this k of 4 would translate it 4 up. So I have something similar here with b. I've got the cube root function, but my transformations really do the same thing. So I see I have a negative inside here, and I have an 8. So that's going to be my a, or what we looked at on the sliders in Desmos was our b value. Okay, so my graph here doesn't have any translations because I don't have any other number here or here, so I just have a shrink. Okay, so I shrink this by a factor of 1/8, and it reflects across the y-axis because I have this negative sign here.